Hey everyone, I wanted to talk a little bit more about 5.2, which is the uniform distribution. There's actually an Excel sheet, your favorite, that I made for chapter 5 and chapter 6. So I kind of wanted to have our walkthrough manual, kind of straight lecture style for 5.2. But now that we've done that, I want to look at it through the lens of Excel. So the way that Excel is going to work is that you just need to tell it what A and B are. So this is going to give you probabilities based on a uniform distribution. So if we look at, oh, and it'll give you your mean and your variance and your standard deviation. So let's go ahead and look at this first example here. If I could zoom in, that would be great. So remember, we had this example where people were following a particular weight loss program. They lose between 6 and 15 pounds a month, whatever, who cares? So for us, we were looking at this as a uniform distribution where A was 6 and B was 15. So the cool thing about what Excel is going to do for you is you just need to put in 6 and 15, right? So in the blue cells, that's where you want to fill in your info. What it computes for you is your PDF, right? So this is giving you a decimal, but you can always convert this into a fraction by just right-clicking and going to format. You can select fraction, up to 3 digits, whatever, that's great. So you would see it's 1/9. It doesn't matter to me if you're a fraction person, if you're a decimal person. It also computes your mean, your variance, and your standard deviation. So for this example, we computed the mean, standard deviation, and variance by hand, but it's already done for you in Excel if you like to do it that way. So notice that we got 10.5 as our mean, check, that matches Excel. Our variance was 6.75, that matches Excel. And then our standard deviation was 2.6. So if I had had Excel round this to 2 decimal places, great, all matching there. The next thing it's going to do for you is compute some probabilities. So in part D, we're asking, what is the probability that X is greater than 12? So in order to have Excel compute that for you, you need to give it a starting and an ending value. So notice here it's telling us that C has to be at least 6 and D has to be at least, or no more than 15, right? Because our probability distribution just goes from 6 to 15. So I know I'm starting at 12 and it just says, oh, what's the probability that X is bigger than 12? Well, fine, yeah, X can be whatever, but we know that after 15, it's just all 0. So I'm going to put in 12 to fix 15. And you can see that it's giving me the 0.333. That's the same thing as 1/3. If I wanted to do the probability that X is less than 9, then that means I want to start at my lowest possible value, which was 6, right? That was our beginning value. And then I want to go up to 9. Guess what? It's giving me 1/3 again. If I wanted it to be between 9 and 12, I just enter 9 and 12. Guess what? It's 1/3. If I wanted to know the probability that it is between, I don't know, 6.127846 and 7, it'll compute that too. The thing that this will not compute is it will not compute conditional probabilities, but it can help. So remember that the conditional probabilities is just a ratio, right? So in example G, we're given that it's greater than 7. So we need the probability that it's higher than 7. So that's 7 to the max, 7 to 15, right? And then I also need the probability that it's between 7 and 8.2. So now that I have those 2 probabilities, right? So this is for my conditional. I've computed my 2 probabilities and all I need is just the ratio between them. So I just need that 0.133 and I need that 0.88, blah, blah, blah. And I got 0.15. So let's take a look and, oh snap, that's it, we did it. So I'm not smart enough to have it do conditional probabilities for you, but I can get you to the penultimate step. So hopefully that helps. We also have an Excel sheet for the normal distribution, and I'll be putting that at the end of the 6.1 and 6.2 lectures.